Hello, welcome again. We are solving some questions of machine design. The topic is bolts, shaft, uh, sliding and rolling contact bearing. Question number 21 is a natural feed general bearing of diameter 50 mm in length 50 mm operating at 20 revolution per second carries a load of 2 kN. The lubricant used has viscosity of 10 millipascal second. The radial clearance is 50 micrometer. The Summerfield number for the bearing is option A 0.062, option B 0.125, option C 0.25 and option D 0.785. So here diameter of the bearing is given as 50 mm or 0.0 meter. Bearing is given as 50 mm or 0.05 meter. Revolution per second is 20. Load is given as 2000 Newton. Okay. Load is 2 kilonewton or 2000 Newton. Okay. And radial clearance is given as 50 micrometer. Okay. And viscosity is given as 20 millipascal second or 20 into 10 power minus 3 pascal second. Okay. So from this load and from this D and L, we can find out pressure. Taking projected area and taking this load 2000. So the pressure is your zero point 0.8 Newton per m square or 0.800 per 6 Newton per meter square. Okay. So now the Summerfield number is Zn by P bracket D by C whole square. D by C is your R by C1. So D is the diameter, C is the diameter clearance, and because this is the ratio of diameter and diameter clearance, and it should be equal to radius and radial clearance. Okay, R is radius and C1 is radial clearance, and radial clearance is given as 50 micrometer, and radius is your 25. Diameter is 50 mm, so radius is 25 mm. So converting this into mm, that is 15 meters per minus 3, so that will be d by c will be r by c1 or 25 by 15 meters minus 3 let square into z is your 20 newton or 3 minus 3, and n is 20, and p is your 0.8 meter per 6. So Summerfield number is 0.125. So answer is option B. So answer to question number 21 is option B.